Good morning, dear children. So last class we have completed section A of our chapter Laws of Motion, isn't it? So what all things did we learn there? In that section we were discussing about force, isn't it? Force is an external cause which can change the state, direction, speed of a or size or shape of a body. We also learned about contact and non-contact forces with examples, isn't it? Now we will move to section B of our chapter. Now, in the previous chapter, we have discussed about the terms rest and motion. Do you remember that? A body can be only in a body can either be in the state of rest or in the state of motion. That is, only two states are there for a body. Now, when can you say that a body is in the state of rest? If its position doesn't change with the surroundings. If the position of a body changes with the surroundings, we'll say that the body is in motion, isn't it? Now, in order to produce motion on a body, what is needed? How can a body move? How? When a force acts on a body, then it moves, isn't it? So what is needed to produce motion on a body? Force. When a force acts on a body, the body moves. A simple example. Riding a bicycle, where are you applying force? You are applying force on the pedal, isn't it? By applying force on the pedal, the cycle will be moving. Now, in the case of a moving car, the petrol engine will be providing the necessary force in order to move the car. So, in all the cases, in order to produce motion, what is needed? A force is needed. I think that concept is clear. Without force, we cannot change the state of a body. To produce motion on a body, we need a force. Okay? Now, the next thing. Earlier, it was believed that by applying force, a body is moving, and if the body should continue its motion, we should continuously apply force on the body. That was the earlier belief. Okay? So, when you are considering a cycle, so when you are applying force on the pedal, the cycle is moving. And if you want to continue the motion of the cycle, what you have to do? You have to continuously apply force on the pedal. Okay? So that was the earlier belief. By applying force, by applying force only motion can be produced. And in order to continue motion, force has to be continuously applied on the body. But it was not accepted by Galileo. Okay? So, according to Galileo, this concept is wrong. A force is needed to produce motion on a body, but he proved that once force acts on a body, the body will move continuously if no external forces or no other forces are acting on the body. Okay? First, when you apply force on a body, the body will move, and according to Galileo, this motion will be continuous. That is, the body will continue its motion until an external force acts on the body to stop it. We will consider the same example. When you are applying force on the pedal, the cycle will be moving. After some time, when you are not pedaling, what happens? The cycle will move for a short period of time, and after that it will come to rest. Isn't it? So, by keeping this concept in mind, earlier scientists told that if a body wants to continue its motion, you should continuously apply force on the body. But what is the actual case? Why the cycle stops? Because of friction, isn't it? When you are pedaling, the cycle will be moving. When you stop pedaling, the cycle will move for a short distance, and after that it comes to rest. What is the reason? Due to the friction between the rod and the tire. That is the reason why the cycle stops. If the cycle is moving on a frictionless surface or a very smooth surface. Once you apply force on the pedal, it starts moving, and when you are not applying force also, what happens? The cycle will move continuously. If it is a smooth road, isn't it? If it is a rough road, then the cycle will stop earlier. But if it is a smooth road, the cycle will move for some more distance. That means, what you can say, in order to continue motion, we don't want to apply force continuously. The body stops due to an external force. In this case, it is due to friction. Due to friction, the cycle stops. Okay. So I can give you another example. You are considering a ball. So when you apply force on the ball, what happens? The ball will roll. Now, first you can consider a very rough surface. So when you apply force on the ball will move for a short distance and it stops. The reason is that rough surface is exerting more friction. Okay, friction is more on a rough surface. So the ball will stop earlier, or after moving to a short distance, the ball will stop. Now consider a very polished and a smooth surface. Apply same amount of force on the same ball by keeping it on that smooth surface. What happens there? Ball will move for a long distance there, isn't it? And after some time only it will come to rest. What is the reason? It is a very smooth surface and the friction exerted by that surface is low. Okay. And if it is a frictionless surface, that is no other forces. If no other forces are acting on the ball, then the ball won't come to rest. It will continue its motion. Okay. So this is actually found by Galileo. That is, a body at rest will continue in its state of rest unless an external force acts on it. A moving body, the same thing happens at the case of rest also. If a body is at rest, it will continue in its state of rest unless an external force acts on it. Okay. Then a moving body will continue its motion until an external force act on it. So these are the findings of Galileo. Okay. So is it clear? Once again, a body can either be in the state of rest or in the state of motion. Only two states are there for a body. Now, if a body wants to move, what is needed? A force has to act on the body. By exerting force on a body, we can make the body move. Now, earlier it was believed that in order to continue motion, force has to be exerted continuously. But it was not approved by Galileo. He proved that once you apply force, with that force the body will continue its motion unless an external force acts on it. Okay. So, 2 points were found by Galileo. Which were they? If a force acts, if a body is at rest, it continues in its state of rest unless or until an external force acts on it. If a body is in motion, it continues its motion unless or until an external force acts on it. Now, Newton, Sir Isaac Newton, made these points into a law, and this is Newton's first law of motion. Do you know how many laws are there? Actually, there are 3 laws of motion. For motion, there are 3 laws put forward by Sir Isaac Newton, and this first law actually comes from the concepts or the findings of Galileo. Okay. Actually, Galileo found these things, and all these points or his findings were made into a law by Sir Isaac Newton, and that is known as Newton's first law of motion. Okay. So, now we will move to Newton's first law of motion. I will tell you the exact statement. It's very, very important. Okay. According to Newton's first law of motion, every body continues in its state of rest or motion until or unless an external force acts on it. Did you understand what is that law? Every body, okay, you are considering all the bodies. All the bodies continue in its state of rest or motion. If a body is at rest, it remains at rest itself. If a body is in motion, it continues its motion. Till what time? Until or unless it is acted upon by an external force. So, if an external force acts on it, the state of the body will change. Till that time, the body will continue in its state. Okay. And that is known as Newton's first law of motion. So, what is Newton's first law? Every body continues in its state of rest or motion until or unless it is acted upon by an external force. That is, an external force is required in order to stop a moving body or in order to change the state of a stationary body. Okay. So, is it clear about Newton's first law? And we can't stop with this part. Again, we have to consider many things from Newton's first law. Okay. Now, we are going to divide Newton's first law into two parts. Okay. Newton's first law can be divided into two parts. So, which is the first part? Every body continues in its state of rest or motion. Okay. That is the first part. First part of Newton's first law gives the definition of inertia. Okay. Have you heard about the word inertia? Inertia means it is the tendency of a body to continue in its state of rest or motion. Okay. So, where it is an inherent property of an object. If a body is at rest, its tendency will be to continue in its state of rest. Now, with respect to this room, I am in the state of rest. So, the tendency of my body is to continue my state of rest itself. Once I start moving, then the tendency of the body will be to move. Okay. So, that property of a body is called inertia. And we will be getting the definition of inertia from the first part of Newton's first law of motion. Okay. From Newton's first law of motion, we have every body continues in its state of rest or motion. That means, what is that actually? That is the property of inertia. That is, all the bodies have a property. That is, to continue in its state of rest or motion. If a body is at rest, its tendency will be to continue in the state of rest. If a body is moving, its tendency will be to continue in its state of motion. And that property can be called as inertia. Okay. So, what is the definition for inertia? The tendency of a body to continue in its state of rest or motion can be called as inertia. And the definition for inertia is obtained from the first part of Newton's law. Now, we will move to the second part of Newton's first law. Until or unless an external force acts on it, isn't it? Every body continues in its state of rest or motion until or unless an external force acts on it. So, what are you getting from the second part of this law? Unless or until an external force acts on it. From there, we are getting the definition for force. That is, force is needed in order to change the state of a body. And that is the definition for force, isn't it? What is force? Any physical cause which can change the state, speed, direction, size or shape of a body. That is known as force, isn't it? So, from the second part of Newton's law, we will be getting the definition for force. That is, force is a physical cause which can change the state of a body. So is it clear? We learned about Newton's first law of motion. Now in first law, what all things we learned? We have divided Newton's first law into two parts. From the first part we got the term inertia and its definition. What is inertia? The tendency of a body to continue in its state of rest or motion. That is known as inertia. Now from the second part, we got the definition for force. So is it clear about Newton's first law of motion? Every body continues in its state of rest or motion unless or until it is acted upon by an external force. Now, do you know on what factor does inertia depend? Inertia actually depends on the mass of the body. Okay? Inertia of a body, I told you it is an inherent property of a body. And this inertia depends on the mass of the body. Greater the mass, greater will be the inertia. For example, when you are considering a tennis ball and a cricket ball, which one is massive? Which one will be having more mass? Is it for a cricket ball or a tennis ball? Naturally, it is for cricket ball, isn't it? Mass of a cricket ball is more than that of a tennis ball. Now, which one is easier to stop? If a cricket ball and a tennis ball is coming, and if you want to take a catch, which one is easier for you to stop? Naturally, it will be the, which one? Tennis ball, isn't it? It is difficult to stop a cricket ball. Why? Because its mass is more. But when you are considering a tennis ball, since its mass is less, we can stop it easily. Okay? So, is it clear? Inertia depends on the mass of the body. Inertia is the tendency of the body to continue in its state. So when a cricket ball is coming, what is the state of that cricket ball? It is moving. It is in the state of motion. So what is the tendency of the ball? The tendency of the ball is to continue its motion, and at the same time we are going to stop the body by taking a catch, isn't it? So tendency of the ball is to continue its motion, and in between we are going to take the catch. Since the mass of this body or the ball, cricket ball is more, it will be difficult to stop this cricket ball. But in the case of tennis ball, it will be easy because mass is less. Another one. So if you want to move a loaded trolley and an unloaded trolley, okay? Trolley. One is loaded and the other one is unloaded. That is, nothing is there in that. So which one is easier? In order to move a loaded trolley or an unloaded trolley, it's easier to move an unloaded trolley. Why? At first, the loaded as well as unloaded trolleys are in the state of rest. So according to inertia, what is their tendency? The tendency of both the trolleys are to be at rest itself. Okay, so by applying force you are going to move it, but the tendency of both the trolleys are to continue in its state of rest. So since mass is more for the loaded trolley, then what happens? Inertia will be more. So it will be difficult to move the loaded trolley than the unloaded trolley. Okay, so is it clear till this? We were discussing about Newton's first law of motion. Then from there, we got the definition for inertia as well as the definition for force. Then the next point what you have to keep in mind is inertia depends on the mass of the body. Okay. So thank you, children.